Dear learners, we will discuss about one of the physical properties like your refractive index. In 1621, a Dutch physicist called Wilbrod Snell gave relationship between angle when light passes from one medium to another medium. In our childhood, we have seen that when we are igniting a torch on a particular medium, then there was refraction of that light ray. Either you are igniting torch in water, you are igniting torch on your mirror, or the major pastime in our childhood was we were supposed to take that lens capturing your light rays and allowing that light ray to pass in a particular direction. So there is change in direction, right, from incident to refraction, and this relationship is studied by the Wilbrod Snell in 1621. When a beam of light is allowed to pass from less denser medium to higher denser medium or vice versa, then there is change in its direction. On your display you are having a white colored beam passing from a quite denser medium to less denser medium, that is from dark black to coal black. When that light ray strikes on the interface and passes from dark black to coal black, there is change in its direction. In the same way, when that passes from less denser to quite denser medium, that is your coal black to dark black, there is again change in its direction. But right now the white colored beam is refracted into various colors, and they are the reflection of their wavelengths. When a beam of light is permitted to pass from a dense medium like your air to a denser medium like water, the light ray turns toward the normal plane. As on your display, you are having dotted line as your normal plane. As you are observing the white colored air medium and the blue colored water medium, when the red colored light ray is allowed to pass from that interface of air and water, the angle of incident and angle of refraction is there, alpha 1 and alpha 2. So the change in the alpha 2 is quite greater than alpha 1. What it indicates that the change in direction is toward the normal plane. And when a beam of light is permitted to pass from a denser medium to less denser medium, the light ray turns away from the normal plane. So the white colored fish targeted indicates that there is movement away from the normal plane. So this change in direction is nothing but your refractive index, which is the ratio of velocity of light in any selected medium to the velocity of light in vacuum or air. Means in order to have the relationship between this change, you need to focus on velocity of light which is observed in selected medium in contrast to the velocity of light in vacuum or air. Let's understand it by means of this graph. You are having interface separating air and water. So the angle of incidence, that is I, made by incident ray, and the angle of refraction made by the refracting ray, that is your R. So the ratio between these two mathematically expresses your refractive index, and that is nothing but ratio of velocity of light in selected material, that is your C, to the velocity of light in vacuum or air, that is your V. This refractive index is a unitless and dimensionless quantity. The Snell's law can also be used to describe refractive index. In his statement, Snell states that the refractive index is a ratio of angle of incidence to the angle of refraction. So the refractive index is given by sin I, that is sine of angle of incidence, to the sin R, that is the sine of angle of refraction. So this refractive index is a distinctive property of liquid. Why you are referring that as a distinctive property of liquid? Because the density of liquid, when you are allowing light ray to pass from that less denser to quite denser or vice versa material, this refractive index will be helpful to have differentiation between the density. The refractive index of most of the substances is more than air, and the reason is the majority of material is denser than the air, and thereby speed of light in air is more than reference substances. Means if you are allowing light ray to pass, then the velocity of light ray in air will be more comparative to your reference substance. Here is list of some of the materials along with their refractive indexes, where you are observing, in contrast to air, alcohol, acetone, diamond and glass, the air having refractive index 1 which is supposed to be changed from air to the glass. In order to deal with measurement of refractive index, you can use the instrument called as refractometer. There are different types of refractometers like your Abs refractometer, full fridge refractometer, or you can have immersion refractometer. The most common laboratory scale refractometer which is used is your Abs refractometer, which has advantage that it is very compact and thereby can occupy in a very less space with ease of handling. Along with this one, the requirement of sample for Abs refractometer is very less, and you can determine refractive index of a large number of material. As like another methods, refractive index can operate with the ordinary light as well. The schematic representation of Abs refractometer is shown on your display, which consists of the parts like your telescope, you are having prism assembly, scale and the adjusting screw. Every component has its own role. Telescope is used to observe the changes in the direction of light rays, whereas two prisms, your illuminating prism and measuring prisms are there. These two prisms are separable to place sample as a thin film within them. You can use scale for calibration of refractometer, and also scale is used for measurement of refractive index of sample. In the case of Abs refractometer, adjusting screw has a function to adjust light such that half black and dark black or half black and half bright circle. So this appearance of half black and half bright circle will give you accurate reading for the refractive index. So the various parts of the refractometer are having their different functions. Like telescope is used to observe changes, prisms, that is your illuminating prism and measuring prisms are there, scale is used to calibrate refractometer, and adjusting screw is used to adjust light. How this Abs refractometer works? The sample whose refractive index is to be measured is placed between the two prisms as a thin film. Once you are placing your sample between these two prisms, you are allowing your light to enter from lower side of refracting prism. In our assembly, we have seen illuminating prism and your refracting prism. So when viewed through telescope, when you are observing the direction or change in direction of light ray through telescope, you can have either dark band or light band, or you can have combination of light and dark band. The adjusting screw is then slowly rotated, and by means of rotation of this adjusting screw, the circle will change from half dark to half bright. When these half dark and half bright spots are observed, you can record your reading. So your reading by means of recorder is the reflection of half dark and half bright band. By this way, you can determine angle of incidence and angle of refraction so as to have the value of refractive index. Why it is essential to understand or to know the refractive index? There are wide range of applications of this refractive index. By means of refractive index, you can understand purity of sample. Every sample has its own refractive index. So the alteration or change in refractive index will point out that the presence of third substance is there in your sample, which might be your impurity. So you can have the exact refractive index value as the determinant of purity of sample. In the same way, as you are changing concentration of your solute in your solution, you can have different refractive index value, and by means of this you can also identify what kind of compound is there or what are the composition of your compound. In the same way, it is used to determine the molar refraction of compound, and this molar refraction gives you information regarding structure of your material, the location of your material. The refractive index can also be used for determination of molecular weight and structure of organic compound, and it gives you the characteristics of solid, liquid and gases. So these are the wide applications, qualitative as well as quantitative applications of refractive index. Thank you.